Hello class, I'm your lecturer Dr. Fan Man for CM3261 Environmental Chemistry, and today we'll go through the next part of this segment called the outdoor pollution. So there are many different kinds of air standards that are here around the world with regards to what constitutes air pollution, and it varies from country to country, but there are guidelines that set up by the WHO, the World Health Organizations. So in Singapore, where we live in or where I teach at NUS, we have our own measures of air quality standards, which is the Singapore Pollutant Standard Index, or we call it the PSI. So the haze PSI's highest record was set in 2013, right, when we hit 401, which was in the hazardous region. Do you remember that in the last class I talked about in 2013, it was a phenomenal year? I thought that was the worst, that we all had to wear masks until this year. So now in the outdoor pollution segment, we'll be talking about the 5 parts here. Number 1, nitrogen. Number 2, photochemical smoke. Number 3, industrial smog. Remember smog? Smoky fog. Number 4, particulate matter, PM. And number 5, the environmental effects of air pollutants. So first, about nitrogen. Why did we talk about nitrogen? Nitrogen in gas. Why? Right? But the thing is, remember, nitrogen consists in the atmosphere and air about 78 to 79% here, and the NH triple bond is just very inert. It's so hard to break, right? But the thing is, the source of the nitrogen actually comes from the combustion of fossil fuels in the engines here due to the extremely high temperature. So the nitrogen N2 and oxygen O2 will only react in a very high temperature environment greater than 1600 Kelvin. Take note, Kelvin, okay? So this kind of environment exists primarily in combustion engines. Okay, so these are not produced by burning wood or coal. In your barbecue, when you fry a chicken wing, barbecue chicken wing, you don't get the oxides of nitrogen here. The N2 will just stay as a covalent triple bond here with a sigma and 2 pi, not with a formation of the N2O or NO2. Those brown smokes there, they are not your NO2 from barbecue. So you should note that, right? The nitrogen comes from the air, the N2, right? But in certain environment where there's enough energy to overcome the activation energy, like we talk about in the combustion engines, right? Then you form an NOx, the oxides of nitrogen, right? And the thing is, when this NOx reacts with water in the presence of oxygen here, they can combine to form your secondary pollutant, your nitric acid, right? Which is an oxidizing agent. So this oxides of nitrogen has varying health impacts that includes the irritation of lungs, aggravations of respiratory illnesses such as asthma, reducing the lung growth, stop growing tissues, and functions in children. So imagine a neighborhood with high amount of NOx, with lots of children growing up. This is not safe for them because when they grow, it doesn't mean that organs grow proportionally. The lungs might stop growing. So it is extremely important that we should eliminate or reduce the NOx from the environment because it plays a very key factor for the photochemical smog during the ozone formation, right? And this link to the next part about the photochemical smog. Remember smog, smoky fog. We join the word to form smog. So photochemical, photo means you use a light, right? In this case, UV light here. One component of this photochemical smog will be the near surface ozone here. Remember the printing, the photocopying machine here, the ground level ozone. So this comes about when the atomic oxygen is released from nitrogen dioxide by the absorption of UV radiations. Remember your UV rays, right? Allows the bond to stretch, and when the ray energy is too high, and what happens? It's like a spring, right? You overstretch it, you break, you form atoms. So when it reacts with oxygen to form ozone, so the ozone, which is O3 with a double bond and a dative bond, there's a sigma bond here, but it's a bit weaker than the double bond. It reacts also with the VOCs, the volatile organic compounds in the air. So the ground level ozone affects the respiratory system by causing a shortness of breath. We call it SOB. Now something else, SOB. Okay, so medical doctors, you go to hospitals say, oh, I've got SOB. That's shortness of breath. Okay, and in medical terms, it's called the dyspnea. Coughing, it also cause sore throats, and also aggravations of asthma and the chronic bronchitis. So the second component of photochemical smog are the acid particles in air. So you see the PM, right? The particles, some are neutral, some are acidic. So how do the acidic part occur? It occurs when the nitrogen dioxide, specifically NO2, right? It forms nitric acid HNO3 with the moisture in the air, right? Due to the humidity, especially Singapore here, right? We're super wet in the sky, right? So when we inhale this nitric acid, it causes the decreased lung function capacity, right? So the lung can't function healthily because it is no longer just dry. You see what I mean? And it also causes increased respiratory symptoms such as the airway irritation, coughing, or difficulty breathing. So just imagine, right? It is the feeling of if you dive into the pool and you choke, you drink water here, right? You have some of this water in your windpipe, right? Or you drink water and you got a distracted thought, and then you see water going to your to the esophagus, right? The part where you air should go in here, and then you don't feel good. That's how it feels here, but of course less severe. Now, the third and last component of this photochemical smog is called the PAN, peroxyacyl nitrate, right? PAN here, the PAN, right? It occurs when the hydrocarbons, oxygen, and the nitrogen dioxide, right, in a trio reacts together in the presence of sunlight here. It is a photochemical reactions here. So these peroxyacyl nitrate are very potent respiratory and eye irritants. Why eye irritants? Eyes is very wet. Okay? Allows the solution of any acidic gases in the air. That's the reason why we cry a lot when we cut onion, because when the onion peels, right, you release a lot of sulfur dioxide here, it goes to our eyes, it's wet, right, dissolved to form what? Sulfuric acid. Acid. Oh, we just tear to let it go. pH is too low. Okay. Now next part, we talk about the industrial smog. So we have the industrial smog. There's a production of sulfur oxides and carbon oxides. When we talk about sulfur oxides, we mean sulfur dioxide and sulfur trioxide. But SO2, sulfur dioxide, is the natural form of the sulfur oxides. When we talk about the carbon oxides, there are two, right? CO and CO2. So the sources of industrial smoke comes from the fossil fuels in sulfide ores, right? Many of these rocks or even ores, when you have the metal strap, they are sulfides, the iron sulfide, right? You know, fool's gold here, iron disulfide. It looks like real gold on the surface, but you know it's not gold because you can just take a lighter and burn it. There's a Chinese saying, if I may read in Mandarin, it's called 真金不怕火. So if it's real gold, you burn it, right, it will just remain as golden. But if you are having a fool's gold or fake gold, FeS2 iron disulfide here, when you put on your splinter and light a fire to that iron 2 sulfide, guess what happens here? You decompose. So the sulfur content is fuel dependent, right? And the brown coal, so in coal there's also many kinds of coal, right? There's a high sulfur content even in some fossil fuels like the petroleum from Nigeria is very high in sulfur, so that's why they're cheaper than those from Venezuela. So it's not like, oh, all the petroleums are the same kind. There's different amount of sulfur, and because when you want to remove sulfur, you want to reduce the amount of sulfur containing oxides produced, right? So if the fuel contains a lot of sulfur, it takes more mechanism to extract the sulfur out, to purify them, and that's why you have added cost. And of course, these petroleum are of lower quality or less pricey. Okay. So back to what we talk about here, sulfur content, right, is also found in coal, brown coal, right, compared to black coal that has a bit less sulfur here, and then black coal contains more sulfur than oil. So on one hand, brown coal is less carbon rich than the black coal. Remember, brown coal contains more sulfur than black coal, which means it contains less carbon than the black coal. because imagine you have 100% scale, right? You have more sulfur means the constituent carbon is less, so it's proportional. So you have more carbon, you have less sulfur. Okay. So the coal of the marine origin also contains a higher sulfur, those by the coastline, as compared to the coal near the fresh water. This is something you should know a bit. And the health effects of the CO, right? Although it's neutral, carbon monoxide, but you know what happens, right? You just annihilate organisms, mammals, right? Cardiovascular effects causing the breakdown of the central nervous system, asphyxiations, right? That's how people commit suicide. They burn coal in an enclosed room, play their PlayStations, their Xbox, and suddenly they feel very tired and they go to sleep and never wake up again. So, if I may make an advice here, try not to sleep in a vehicle with the engine turned on and the air condition turned on with the windows up. Because when the engine is stationary, right, the car is stationary here, you're burning fuels, right? But there's no fresh air going to the combustion engines here. So what happens is you might have a very high likelihood of incomplete combustion, and you know that the circulations of air in the car here, right, inside here you have CO. What happens if you have CO? The human who's very tired breathe in, right, sleep, sleep, and the more CO we breathe in, we sleep more, right, and might not wake up again. So be very careful. If you want to sleep in the vehicle here, wind down your window, please. Okay. All right. So we talk about how CO can cause acute respiratory infections here, and sulfur dioxide can either form sulfurous acid H2SO3 or sulfuric acid with water or mucus or in our eyes here, right? And these acids of sulfur aggravates asthma and also increase the risk of lung cancer and chronic bronchitis. Now the next part is on particulate matter, the PM. So there are many sources of PM, right? So firstly, it comes from the acid neutralizations in the air, where they exist as secondary pollutants from their primary pollutants being the sulfur oxides, right, and nitrogen oxides. Remember, the primary pollutants are evolved, and then when they undergo further chemical reactions, they become the secondary pollutant. So these SOX, NOx, right, they exist from the soot, just pure carbon, just carbon, from the fossil fuels coming from the combustion engines, even power plants. Right now it's bright. Last night was dark. You can see over there smoke, fire, yeah. And also in the burning of woods and organic matters here. You don't find a lot of burning of woods in Singapore, but try to visit the Amazon if you have a chance to. Yeah, pretty smoky there. So in the industry, I would say that near the west of Singapore, could be towards the Jurong side here, near Chinese Garden, there's some industrial area here. There might be some kind of smell that you might not experience near the central part of Singapore here. Try to make a trip there and just do some excursion and breathing. Of course, you might not know how the burning of wood smell like. Let me try to find something for you. Okay. Now, in the industry, the particulate matter comes from mining activity. So Singapore, we don't have much mine. It is very hard to describe. But I just want to connect that, in a mine, right? In mine, underground mine, where you mine iron ore, where you mine metal from the ore, when you mine coal, right? Definitely you have some solid particles, and it is something that's too tiny and just fly around. We call it particulate matter. So these kind of PM are also found in smelters and also found in the ceramic and cement industry. Right. So if you have a choice here, you may want to avoid the construction industry because when you work there, you might wear a mask, but how much can your mask filter this PM using the size exclusion principle? Okay, so this kind of PM also appears as road dust because of the abrasion for the tires, right? When you have the frictions here from the tires, although they're soft, right, but not so soft, And what happens is the friction causes the road asphalt, right, to grind, just grind. Okay, and then you have some of this release of the solid particles that exist as PM, particulate matter here. Pavements as well, when people run, when the bicycle grind on the pavement. So these particles can get lodged in the respiratory airways that causes a variety of respiratory diseases. Okay, so next we'll talk about the environmental effects of air pollutants.